IC is our integrated geological software. Built from a reliable data management platform, it offers a suite of tools designed to make the geologists, stratigraphers, and engineers more efficient by simplifying their workflows. IC has a new, modern, intuitive interface that allows users to work seamlessly and focus on what the data is telling them. IC is a multi-discipline package promoting integration and collaboration across teams and departments. An IC database gives the bigger picture, enhancing insight and perspective. IC allows teams to organize their data into definable categories for easy access. A team can flexibly define their database structure and import their data into grouped data types that are related to one another to allow users to quickly and easily find the data that they're interested in. This structure is applicable across all wells in the database, meaning that you have the same blueprint database structure across all wells. While this structure is fully flexible, only users with sufficient permission are allowed to alter the structure, meaning that it is also a safe, locked structure if it needs to be. To populate a database like this, IC accepts many standard file formats, including LAS, ASCII, and also links to external databases. You can import data and export data between different IC projects, and you can then save and export your data once your interpretation is finished. This IC database consists of several different projects in which I have grouped together associated wells into projects. Under each project, I have a list of wells, and under each of the wells, I have the data types and tables that are populated for these wells. So if I click on a well, I can see exactly what data I have for this well and go on to open the tables in which the data is directly stored. This is my map of a section of the North Sea. On this map, I have displayed several different GIS shapefiles showing the outline of the nearby coastlines plus the license blocks within this area. This example is the North Sea, and I have a field that is to the north of the Outer Hebrides. I'm going to zoom in on my field wells using the toolbar in the map. With this, I can see the arrangement of my wells, including their well path. I'm going to go and reorganize the layers in this map to show my gridded surface in the foreground. This shows me the thickness of a reservoir unit that is of interest. On top of that, I also have plotted some lithology bubbles. These are also focused on the Oscar unit that is plotted in the grid and shows me the lithology within that unit. Since this lithology is related to a stratigraphic scheme that I've built up in the database, I can then move through my scheme to see the difference compared to other units within my sequence. So currently I'm focusing on this Oscar formation, whereas I can use the built-in toolbar to jump through the different layers in my sequence to see what lithology I have here. So in some of these wells I can see that there is an unconformity, and looking now at the data, I can see that there is indeed an unconformity above the Oscar unit, going straight to the Danio unit. I can move through the sequence at will and even go up a level in the hierarchy to look at the groups involved. So now moving down back through the sequence, I can see this puffer group and show that it has a greater variety of lithologies than its Oscar child unit. From this, I would also like to highlight which wells meet certain criteria. This is done using a well query, where I can either choose a query that I have previously created or set up a query that answers certain parameters. So to do this, I'm going to go and create a new query looking at wells that have the clown unit. So let's say the clown formation within the puffer group. If I add this to my query, I can then test it to show that I have 19 wells that answer this query. All that remains is to give the query a name and select a color to highlight it with. Thus, when I apply to a map, I can see which wells answer my specific query. From this map, I am going to draw a correlation. So if I do this directly from a map, I can also choose from my ribbon at the top the wells that I want to include in my correlation by selecting and clicking, and then using the correlation wizard, I can step through and define exactly what I want to see in my correlation. So in this correlation, I'm going to focus solely on the depths over which I have formation data, apply those to all those wells, set a scale and separation, and choose a template. So I'm going to choose one that includes my chronostratigraphic data, and then build a chart in a few simple clicks. This has created a chart showing my lithology data in the right-hand columns and then my chronostratigraphic data in the left-hand side. I can see that in some of these wells, the chronostratigraphic data is not yet populated. So to fill this, I'm going to use the stratigraphic building tools within IC. So since I have already created a stratigraphic scheme, I can then use this to populate my age data and my chronostratigraphic intervals. So using first of all the tools to build my age in millions of years, I'm going to use my lithostratigraphic data, of which I already have ages for, to then build my chronostratigraphic age data. And if I process this, I've now populated this column in each of my wells. And moving on to the third function, I can then build up my chronostratigraphic data from my age column. Now choosing my Gradstein scheme, I can select the scheme that I'd like to abide by that is already populated in some of these wells, and then simply process to populate this for the rest of the wells in my chart. So now I can see that I have these columns now fully populated for the remaining wells. To then interpret this, I'm going to build ties across my correlation. To do this, I have a built-in tool called the Ties Manager, where I can select the data type that I would like to tie. So for this example, I will choose my formation data, and I will select the wells I'm tying and click. In one click, I can populate ties across my whole correlation. From this, I can also flatten on specific intervals. So if I flatten on this light blue interval, I can just click on it and then flatten on its base. So now everything is plotted in relation to the base of this Danio unit. Going back to my map, I'd now like to view one of these wells in more detail. So if I right click on one of my wells, I can open up a summary chart. Now I have several charts saved as a summary, which I can use as a layout for my quickly opened summary chart. So this well includes data that is plotted in a well stick. I also have there several cross plots and a map showing the location of the well. Now this is a heat map, but using my data summary tool, I can see that since this is supposed to be showing petrography data for this particular well, which is number 13, I can see that there is no petrography data available for this well, hinting at why it is not populated for this chart. So I'm going to apply this same layout of summary chart to another well. I don't have to build everything again. I can use the apply well tool to select another well and just double click to then redraw the whole chart for the data for that particular well. Again, I can use the data summary to choose which well I can use with this petrography data. I'm looking at this A1A well. So when I go to my apply well tool, I can double click on this well and I can then populate the chart with this well's data. Now looking at the heat map, I can see it's looking at the right well. If I add data types, I can see the data is present. If I click OK, I can then see the data in that heat map and then use that to interpret possible mineral assemblages to work out rock types at these specific depths. So using the colors in the heat map, you can plot these together and work out which rock types are then present. In this well stick, I have a whole range of different panel types. I have simple intervals plotted with colors. Now these colors, as we could see in our correlation, are consistent across every well. This is because IC uses dictionaries. Dictionaries are built using the data in the database. They can be manually created. So we can then define the names that our units are called, setting a specific spelling scheme, and also defining the ages that they cover. And it is also possible to define its parent unit. So when you apply a parent-child scheme, you know exactly where in the hierarchy this unit sits. Now these dictionaries means that your data is always plotted consistently. So when you build a correlation, it is very easy to follow across the correlation the specific unit of interest. Without these, you would end up having to set colors for each well and you'd end up with different shades. Now with these dictionaries, you can then have a specific shading for specific units and abide to that throughout your database. We can also see that in this lithology column, I have shading set up. Now this comes from a graphic dictionary showing specific lithotypes and their shading. This could be from an industry standard textbook, or it could be something of your own design. These are also used to plot things like your biostrat data and your casing data. In this example, I have some sidewall cutting cores, plotting the lithology of those sidewall cuttings. In other areas, I have a structural plot giving me the paleocurrents down my well, as well as shaded log curves and plotted age data. Looking at a few of other charts in this project, I'm going to take a look at a projection. So here on the right hand side, I've got a projection showing me a line through my map. Now if I zoom in, I've got a map in the corner giving me the location of this projection across my field, and I can see then how the well paths of the wells through that section then interact. Beside these well paths, I've plotted log curves and lithological intervals to show how these are then correlated. I can draw upon my sequence stratigraphy. This here is a chart with my sequence stratigraphic triangles plotted along with a category plot giving me the fossil assemblages throughout those tracts. Now these are plotted using our specialist data type for these stratigraphic triangles. So these tools are really built with stratigraphers in mind to save having to draw out these symbols and plot them in a manual way. We have automatic tools that allow these to be plotted in a few clicks. We also have tools for drillers and engineers. So moving on to my drilling project. In this I have wells that are fully populated with drillers data, that being casings and wireline. I'm able to create charts like this one where I have plotted my well diagram as an image and then plotted it digitally with the caliper data and the casing symbols to show exactly what the casing comprises of, what lithologies it penetrates, and how this correlates directly with the wireline data that has been logged. The beauty of having a centralized IC database means that you can plot your stratigraphic data alongside your drillers, your casing data, and plot that alongside your petrophysicist data. This means that you can work as a integrated team, sharing knowledge between the teams and building up a bigger picture using all of the data you have available. For production engineers, we have our RPM module. As well as being able to import data from flat files and from external databases, our RPM module allows you to link to an updating data source where you may have your production data coming in periodically. RPM allows you to tap into that, and we can then create a self-refreshing data store based on your production data. For our IP users, we now have connectivity with IP data with an IP database. This means that we can create a common database that is shared by both IP and IC, therefore meaning that you can pick and choose which data you're going to store in IC and which you're going to keep in IP. But your database is essentially shared between the two so that your petrophysicists and your geologists are looking at the same data. You don't then have to update your data set each day. You've already got a centralized data store to keep both of your databases in sync. This interactivity with IP means that we can then go on to view the same wells in our IP software, showing the same data, and be able to use the tools in both packages to build up your interpretation. The connectivity with a Petrel database makes IC a good companion because IC has the tools to quickly and easily build up detailed correlations as an alternative to your traditional seismic interpretation that you would do in Petrel. Thank you for listening. Please get in touch with any questions.